Hello students, welcome. Previously, lesson 25, form 4, topic 4, we were dealing with the seventh aim of calculating Faraday's first law of electrolysis, which was determining the time taken. So today, lesson 26, we want to proceed to the eighth aim of Faraday's first law of electrolysis, which is determining the Faraday constant. So the formula used here, when we are calculating Faraday constant, we can write F capital letter, it will be equal to Q multiplied by Rm divided by M times N, where Q is the quantity of electricity passed and Q can be obtained by using the formula IT, where I is current measured in amperes, T is time, which must be in seconds. So next we are saying M is mass in grams deposited, N is the number of electrons gained or lost, or in other words, the number of Faradays or the value of the charge of a metal. Then F is Faraday, which is equal to 96,500 coulombs. Then Rm is relative atomic mass of element. Let's go to examples. Example number 1, we are told if 1.7163 gram of sodium was deposited when a current of 1 ampere was passed through an electrolytic cell of molten sodium chloride for 120 minutes, determining the Faraday constant. So here we are given the relative atomic mass of sodium, which is 23. So Faraday is equal to Q multiplied by Rm divided by M times N. So Q is quantity of electricity, which we can use the formula IT, where I is current measured in amperes. So the current given here is 1 multiplied by time. The time given is 120 minutes, so 120 minutes multiplied by 60 to convert it into seconds. Then we multiply by Rm. The Rm of sodium is 23 divided by M is the mass deposited, and the mass deposited is 1.7163, so you can see here. Then multiplied by N. N is the number of Faradays. So here we're having molten sodium chloride, so it contains sodium ion, and the charge of sodium ion is +1, then that means the value on the charge is 1. So this is the one that we're talking about. So when we put all this in the calculator, we're going to get 96,486.6 coulombs as our Faraday constant. Example number 2, we are told a current of 1.2 amperes was passed through molten aluminum oxide for 75 minutes, deposited 0.5036 gram of aluminum metal at the cathode. We're asked to determine the Faraday's constant, and we are given the Rm of aluminum, which is equal to 27. The formula for calculating Faraday constant will be equal to Q multiplied by Rm divided by M times N. Q is quantity of electricity passed, which we can use the formula IT, where I is current measured in amperes, that's 1.2, multiplied by time is 75 minutes, but we have to multiply by 60 to convert into seconds, because we are told time must be in seconds. Then we multiply it by Rm. The Rm given aluminum is 27 divided by M. M is mass. The mass deposited is 0.5036 multiplied by number of Faradays. Here we're having aluminum oxide as our electrolyte, so it contains aluminum ion. So the value on the charge of aluminum is 3. So that is the 3 that we have there. When we put all this in the calculator, we are going to get 96,505.16 coulombs as our Faraday's constant. Then lastly, we are going to go to the extended questions. We have only one extended question, and that's question number 3. Kindly try it and submit your answer on the comment section. Thank you for watching.